The title to this chapter may seem a little obscure in its first part and witheringly technical in its second, but both halves will make sense by the end of this chapter. Well, hopefully anyway. Passing it on. What do I actually mean by this? Well, it's a common phrase within the 3ds Max community to describe an object data as being passed upwards through the stack. The base object forms the foundation and its data is passed upwards to the modifiers above it, where it's acted upon and then passed upwards once more. We can see this with this example I have here in the viewport. I've actually turned off show end result on off toggle, and that means that I can actually step through the stack one modifier at a time and actually show you how we end up with this end result here. So as you can see at the base we've got a teapot, then I've got an edit mesh modifier which actually does nothing at the moment. Then we turbo smooth it, which quadruples the number of polygons. Then we got a polygon select, which selects these rings of polygons. We face extrude those outwards. Then we put some noise on those. Then I poly select some more polys. Face extrude those again. We've got an edit poly in there, and that just puts these little rings around here, so we can do the next step. Then we've got a bridge, which is actually carried out with inside this edit poly modifier. Then we've got another edit poly modifier that actually bridges across in the opposite direction. Then we've got another edit poly modifier, and that actually goes in and deletes some elements. It actually deletes the spout and the handle of the teapot. And then finally at the top of the stack we've got a turbo smooth. Now it's important to note that some of the modifiers set themselves up when they are added to an object stack. After that point you can change the parameters of the modifier or go into its sub-object level and make changes, maybe deleting some faces or adding some faces or whatever. This modified object is then passed on up to the next modifier for further changes, and that modifier stores those changes based on the indices of the sub-objects that you modified. When I say indices, every single vertex or face within a polygon model is actually numbered, and it uses these numbers to actually store any sort of selections that you use to make any sort of modification. So you could maybe take vertices 60, 62 and 63 and pull them slightly outwards, and again the modifier would store this change based on the axis moved along and the vertex numbers affected and so on. And this is all well and good, but what actually happens if something below that modifier changes and those indices change as well? So let's say we go back to the first modifier in our object, and that's the edit mesh modifier that you can see here. What I'm going to do is I'm actually going to go in and I'm going to select some faces. Let's say we select this face here and that face there, and I'm just going to delete those faces. And now I've got this gaping hole here which I'm not very happy about, so I'm just going to get these vertices here, just select these vertices, and I'm going to weld them. So if I do selected, I've got quite a high threshold there, and as you can see it's actually stitched those vertices together there, so it's actually welded up that hole, and that's looking pretty good I think. So I'll just deselect that. So I'm pretty happy with the model the way it looks now. So let's have a look at the modifier above it now. I'll just click on the turbo smooth, and as you can see the changes that the edit mesh modifier previously carried out means that the turbo smooth end result is not actually the same anymore. When we actually deleted the faces and weld those vertices together in our first modifier, we changed the indices of the faces and also the number of vertices in the mesh, and we obviously changed the topology. The modifier following it was not aware of this, of course, and in this case the turbo smooth doesn't really care that much about topology. It's not actually topologically dependent. But if we go up to the modifier above, you can see that the selection, which before was a set of concentric rings that actually ran all the way around the teapot, it's not actually the same anymore. And the reason for that is very simply because in the edit mesh modifier, the first modifier in the stack, we changed the topology, and the poly select modifier is most certainly topologically dependent. and you can see we're getting this different result now. You can see these edges, these faces are selected here, whereas previously they weren't. And if we follow up the stack and we actually see what goes on, you'll see that those faces then get extruded, and then they get the noise modifier applied. And then we've got another poly select, and again it's changed quite radically because obviously the indices have changed again. You can see they're kind of in the same kind of place, but they've moved inwards, and they're not symmetrical in the same way that they were before. And previously we had two faces here, two faces, two faces, and two faces. And I think you can see you've actually not got the same number of faces selected anymore, and they're certainly not grouped in the way they were. And then if we follow that up, they get extruded, and you can see now that the other face is actually over here now. If we go back, there we are, we can see this face is selected here. Obviously that face used to be over here, so you know, this renumbering of the indices in the first edit mesh modifier really has, you know, shaken things up quite a lot. And if we go to face extrude again, you can see we've got this result here. Then we've got the edit poly, which originally put in these lines around here to allow these to be bridged. And you can see those lines aren't there now, they're somewhere else, you know. So it's actually getting very messy by this point. Then we've got edit poly modifier, that's actually putting in a bridge, but that's not working anymore, because you know it hasn't got those faces there and the relationships aren't the same. Then we got the next edit poly modifier. It's not working the way it was before. The last one, again, is not working, and turbo smooth at the end. So you can see we've got a result here, but it's not actually working the way it should do. We've pretty much broken it. Now, if I go back down in the stack again, and actually what I'll do is I'll just pin this, and we'll go to this edit mesh modifier here. What I'll do now is I'll actually the pinning didn't actually work in that case, so it wasn't really that useful, so I'll just turn it off again. If I actually go down to the edit mesh modifier and turn it off, you'll see that it all actually works again, and that's obviously because we've just turned off the effects of that modifier and the topology isn't actually broken anymore, as it were. I'll turn it back on again. I can go down in here. I can I've actually got show end result turned on at the moment, and as you can see it's got a ghost of what the mesh is like at this point, as you can see, and it's actually showing obviously the end stack result as well. So if I just select these faces here, these edges, I'll just delete these, and I'll get these edges here and I'll just delete those as well. There we are. Deselect everything. And as you can see, it's just getting worse and worse. So the more we make changes down the stack, you can see those propagate onwards, and the topological dependency obviously means that in the end we're going to get a mess. But as I said, I can undo that very easily just by going down to this edit mesh and actually just turning that off. So this is, you know, it's an interesting enough example. It's a strange little model. It's only really produced just to show how this topological dependency is, you know, pretty important in your workflow. But what does it actually mean in a real world scene? Well, let's actually have a look at two real world examples that I've produced here. I'm not saying they're, you know, anything that you would use in a production, but they do actually show how this topological dependency will affect you in day-to-day work. One example is I've got this very basic character here, which we've seen earlier in this DVD. Obviously it's a bit audacious to call it a character. Obviously it's just a cylinder with some bones running up the middle of it, but for our purposes it's a character, and we'll just quickly see what it does. You can see we've got our animation from earlier, and you can see it's whiplashing and wobbling around, and that's all looking pretty cool. Now the skin modifier is actually using some envelopes in this case to actually weight the vertices in the mesh to each bone. And if I go into the skin modifier and click on edit envelopes, you can see that each of these bones in the skin modifiers, it's brought in these bones, and you can see they're listed here, and each of these bones has got this envelope, and all the vertices that actually fall within that envelope are red, and that means they're rigidly attached to that bone. And